going to be looking at some ideas for finding volume by rotation. So I'm going to make a copy of this document as we get started. When you're doing volume by rotation, you're going to have a lot of circles. So in pretty much every shape that we see throughout this whole thing, you're going to be looking at some type of circles and cylinders, because cylinders tend to be the most common thing related to circle volume. However, in the middle, there will be a small section on spheres. So let's start at the top. For this first one, if I want to rotate QRST around QT, what am I looking at? So I'm doing like a horizontal spin there. And if I'm spinning around horizontally, then that means my radius is going to be this edge that is 7, and my height is going to be 6. And the calculation's a lot easier than you would think. It's just identifying the pieces appropriately. So I'm going to calculate using the link for a cylinder here. And I can make this go on my right side and make my notes go on my left side. We can do them a little side by side. Make ourselves a little bit more space. There we go. The radius happens to be 7. And the height is 6. And it's that easy. Like, it's not a complicated calculation, but it is something that it takes a little bit to visualize which pieces are the radius versus which pieces are the height. Let's try that again. We'll make sure it's going to our clipboard. Perfect. Now for this next one, it's rotating more like in a vertical direction. So if it's rotating in vertical direction, now my vertical line is going to be the radius and my horizontal line will be the height. So my vertical line will be 6 and my height will be 8. And there we go. I screen capture that and put my calculation in there. All right, now let's look at this next one. This next one is a cone, so I'm going to double click up in the header to get this link available to me. I'll pull it over here. The difference between a cylinder and a cone is this divide by 3 piece in there. So now what I want to do is figure out what is my height, what is my radius, type those in here. It just so happens that my height is 5 and my radius is 7. And that gives me this calculation down here. These are very quick problems once you identify what the pieces are, just like we said earlier. Now we have a cone, but rotating kind of in the vertical direction across the horizontal axis. But we still have a radius, and this time our radius is 6, and our height is 8. So I'll put my radius is 6, my height is 8, and it gives me this calculation down here. Capture that, paste it in. Let's say I want to rotate a half circle to create a sphere. Okay, if I'm creating a sphere, and that means I want to calculate or find a calculator for the volume of a sphere. It's 4/3 pi times r cubed. The r is not 6. It's not going to be 6. It's actually 6 is the diameter all the way across. Instead, the radius is 3. Then I will capture that, put that in here, and now I have the volume of the sphere when this is rotated around. All right, now let's get to the pieces that are a little bit harder. These pieces are some kind of combination where we're going to be adding or subtracting. Sometimes we have 2 cylinders where one is cutting a hole out of the middle. Sometimes we have 2 cylinders where one is stacked on top of the other. And sometimes we have this interesting trapezoid that creates what is called a truncated cone. Let's see how that plays out. Let's go ahead and start with this last one and work our way up to the truncated cone. So on the last one here, I got a lot of things going on. Notice that the 9 goes all the way up and down this long side. 5 is MN, which means that PO is 4, and that's marked in the drawing here. The way that I know that it's 4 is because it's the difference between 9 and 5. Similarly, LM is a long horizontal edge. ON is 4, which leaves left over QP to be equal to 3. All right. So let's do part A as the top cylinder and part B as the bottom cylinder, just so they kind of line up top and bottom there. So the top cylinder, if I'm going to calculate a cylinder, I need to know the radius and the height. Well, the radius is 3 and the height is 4. So the radius 3, height 4. That gives me this calculation here of about 113. The bottom cylinder has a radius of 7 and a height of 5. So on that one we have a radius of 7, a height of 5. That gives me this number, 769.6902. There we go. And I need to add those two numbers together. We love our Desmos calculator. So I'll go ahead and type them in. It'll be 113.09 plus 769.69. And that gives me a total of 882.78. I can click on it, copy and paste, and there's my total. All right, now let's look at this next one. This one's different in that it has 2 cylinders, but one is a hole while the other one goes around the outside. So I noticed that to break this down, what I need to look at is what's the big cylinder, we'll call that part A, and then what's the little cylinder. So the big cylinder has a radius of not 3, but 6. The reason it's 6 is because it goes all the way from the center all the way to the outside. And the inside that we're going to carve out is a radius of 3. Oh, pardon me. No, we're looking for the height. We want a height of 10. So our first number is almost 1131. So that will be 1130.97. And then for the inside, our height is still 10, but now our radius is 3. That's about 282.74. So I'm going to add those two numbers together. We have 1130.97 plus 282.74. And that gives me 1,413.71 for my total. Good tip when you're trying to copy and paste things. If you don't want to paste with different formatting, if you hold down Shift and then press Control V or Control or Command V, that'll paste it in there using the formatting that you already have in the document. All right, we just have these last two to go here. All right, what's going on with this cylinder? It's very similar, except it's got like this vertical rotation going on. So let's try and determine how we're going to put these numbers together. I have a 5, a 6, and a 4. Well, the 6 and the 4 together make that long radius for the bigger piece. So we're going to put those together for a long radius of 10. And the height perpendicular to that is 5. So that's this number down here. And then for part B, the inside, the hole that we're going to be looking at. Oh, you know what? We did something wrong. I'm going to come back to it here in just a moment. The hole on the inside is going to have a radius, same height, but a radius of 4. Capture that. I'm just now realizing that I added these 2 cylinders here, but they're not stacked on top of each other. They're intersecting and carving out a hole. So it's not going to be 1,413. Instead, we need to subtract, which gives us 848.23. That would have been more accurate. But let's do the same thing for these numbers. We have 1570.79 minus 251.32. And I'm not really rounding off. I'm just truncating or chopping off after a couple of digits. And that gives me 1,319.47. Okay, how do I make this weird looking shape? This truncated cone or chopped off cone is a combination of 2 cones. It's kind of like the whole cone minus this white empty space cone. So we're going to be doing the volume of a cone, but a couple of times. For the whole cone, all the way from the bottom base to where this would intersect at the top from the diagonal edges, that has a radius of 6 and a height of 5 and 5 put together, so it's a height of 10. So the radius is 6, but the height is 10. And that gives us a calculation down here of 377 about. For part B now, this is the piece that we want to subtract. It's like not there, and we don't see it because it's already been chopped off. It's that top empty cone. And on that cone, we have a radius of 3 and a height of 5. So we have a radius of 3, a height of 5, and that's about 47. So to approximate this total, we're going to say 377 minus 47. Let's just round it off to whole numbers there. So that's 377 minus 47. That gives me 330. There we go. So rotational volumes are not hard to calculate, but they are hard to visualize. This is a series of visualizations to try and show you how these spins turn and create these kind of shapes. And hopefully that will be helpful to you. And that's it. This is a short notes. Thank you.